Hi again, everyone. This video is going to talk about continuity. A function is continuous on its domain if it has no holes, jumps, or breaks. If the graph is continuous, you can draw the graph without picking up your pencil. This function has a domain of negative infinity to positive infinity. Because there are no holes, jumps, or breaks, the function is also continuous on the interval from negative infinity to positive infinity. Looking at the left and at the right side of the graph, we see that the domain of this graph is from -4 to +1. Because there are no holes, jumps, or breaks, the function is also continuous on this entire interval. Because of the arrows on the left side and the right side of the graph, because of the closed circle filling in the open circle, and because everywhere on the x-axis is filled in and connected, this graph still has a domain from negative infinity to positive infinity. However, because of the jump in the graph at x equals -2, we can only say that the graph is continuous on the interval negative infinity to -2 and on the interval -2 to positive infinity. We do not include -2, so we use the open bracket because at x equals -2 is where the discontinuity occurs and where the graph jumps. Similar to before, considering the left end and the right end of the graph, and considering that the open circles of this middle piece are filled in by the closed circles, this function has a domain from -9 to positive infinity, including -9. However, there are two jumps in the graph, one at x equals -3 and one at x equals +2. The graph is only continuous from negative infinity to -3, -3 to +2, and +2 to positive infinity, again using open brackets for -3 and +2 because of the discontinuities and the jumps in the graph at those points. This graph's domain has a lot of empty space in the middle. However, the graph is still continuous over its entire domain. This graph's domain is from x equals -6 to x equals 0. Because the closed circle still fills in the open circle in the line segment. However, the function is not continuous at x equals -4 because of the hole in the line segment. So, to recap, when finding where a function is continuous, first take note of the domain. Start writing the domain. Every time you hit a point of discontinuity, you're going to have to end the interval and then start a new one over. Once you get to the right end point of the domain, then you're done.